here's ever done electronic camming operations? Cam tables and a motor. A few of them, about less than a third of you, okay? Let me hear anybody tell an application why they had to use electronic camming. Anybody?
On the fly cutters.
On-the-fly cutters, like a rotary knife cutter or something that's shearing.
Rotary knife.
Rotary knife, okay, that's real common. Anything else? All right, more people raise their hands than that. If you raise your hand, you must have done a camming operation at one time.
But in general, we wanted to superimpose a file on a base speed, for example.
Okay. Okay, what else? Anybody else?
We made a robot for putting meat in a big box, and the engineer can decide to record the movement between X and I, and we put it in the cam table.
Okay, so basically you did a Moog profile using camming. Okay, any one of those will work. I want to take the one about the Moog profile because there's a unique aspect we can change here in electronic camming. If you notice, we feed electronic gearing into camming. Now, what David was saying, they did some profile. Typically, camming has a master encoder. Okay, you're doing some profile off of a master encoder to produce a cam, like the rotary knife. You're going to look at line speed coming down the line, and the knife's going to roll over and cut the material as it goes by at the right time. It's speed dependent of material motion, you know. But in David's case, it's independent of that. There's just some area and you need to do some path. There is no external encoder to be a master. Okay? But if you look over there, we have control sources. Internal, external, and virtual access. So in the case of what he would do, virtual access would be ideal. You may have an X and Y system that moves in some pattern, but there's no external master. So instead, you do an internal master. You can download an entire profile for camming. Now we can go one step further with that. If we can change parameters between here and here, then we should be able to change how fast or slow it sees this virtual access going, or multiply or divide that virtual access speed coming in, which means we can change how fast it goes through camming. Okay? So that means the speed of the path can be changed by changing how quickly it sees the frequency come in. Since there's not a real axis that it's mastering off of, you know, then the virtual axis, we have to change something. So we have a multiplier and divisor of the time base coming in. That's how we speed up and slow down the cam. But what if you needed to change the scale factor? How the amplitude of that cam table? For example, what if you have some cam table that looks like this, okay? But the next day you want it to push harder, like that, okay? That's an amplitude change. Whereas if it was a frequency change, it would be like this, and that would be higher frequency, okay? Lower frequency would be like this, okay? This part, this way, is time. Time is the virtual axis coming in here, or any one of these axes, and changing the amount of frequency that you see off of that. How fast you multiply and divide this count coming in. That's the speed of it. That changes it this way. But the amplitude is how we change the value in the cam table itself. Okay? So in electronic camming, we have the ability to change the frequency or the amplitude of the cam table.